Hello and welcome to Call of Chemistry. In this video, we will discuss a very important application of hyperconjugation or no-bond resonance. By this, we can easily dictate the most stable conformation of some certain compounds. In the last video, we understood how sigma bonded electrons involves in conjugation, and that is nothing but termed as hyperconjugation. And another type of hyperconjugation is also possible where non-bonding electrons involves in hyperconjugation. We'll understand by some examples. Suppose you have to draw the most stable conformation of this compound. So if we draw this compound in chair conformation, then two possible chair conformation are there. What are they? So these are two chair conformation of this compound, where this is the trans form, where this lone pair of nitrogen and hydrogen are in trans position, and here the lone pair of nitrogen and hydrogen are in cis position. So this is the trans form and this is the cis form. Notice that this lone pair of nitrogen is in axial position, and in cis form this lone pair of nitrogen is in equatorial position. Now, which one is most stable between the trans and cis form? We will answer this by applying a special type of hyperconjugation where non-bonding electrons or lone pairs involves in hyperconjugation. Well, this phenomenon has a popular name, and that is anomeric effect. Now, if we draw the lone pairs of oxygen properly, then it should be in equatorial position and these lone pairs should be in axial position. Similarly, this will be the equatorial position and this will be in the axial position. Now what anomeric effect tells that this is the sigma bond between carbon and nitrogen, then the sigma star will be such way. So this is the sigma star of carbon nitrogen. Now what the anomeric effect tells that if the lone pair of oxygen, that is here, and the sigma star of carbon nitrogen bond, that is over here, are in parallel position, then this non-bonding electron interacts meaningfully to this sigma star. So that is a non-bonding to sigma star of carbon nitrogen interaction takes place, and that is a no bond resonance type interaction. Now that interaction is possible only when the non-bonding electron pair and the sigma star will be in parallel position. That means this axial lone pair will have no interaction with this sigma star as they are not in parallel position. So no interaction is possible. In other words, we can say that if this carbon nitrogen bond and this oxygen lone pair are in anti-periplanar position, then this type of hyperconjugation takes place. So anomeric effect will occur only if these indicated bonds are in anti-periplanar position. Now if we count the total number of anomeric effect present in a molecule, then we can easily dictate which conformer is most stable. So we have to draw it freshly, otherwise you cannot understand. So this is the equatorial lone pair and this is the axial lone pair, and here this is the axial lone pair of nitrogen. Now if we count the total number of anomeric effect present in this trans form, it will be, we can see here in the transform only one anomeric effect is possible, that is only this is in anti-periplanar position, that is sigma star over here, and this is meaningfully interacts with this sigma star. But this lone pair does not involve in anomeric effect because this is not anti-periplanar position. Similarly, this lone pair also does not involve in anomeric effect because this is not anti-periplanar position. So here we can see that in the transform only one anomeric effect is possible. On the other hand, in the cis form, we can see that here also an anti-periplanar position. So one anomeric effect is there. Again, this also an anti-periplanar position. So here also, so it is also an anomeric effect. But this lone pair does not involve in anomeric effect because it is not anti-periplanar position. So here you can see that in cis form, two anomeric effect are possible. Now, as the anomeric effect is a stabilizing effect, if the number of anomeric effect is increases, then the stability of the conformation also increases. So here you can see that cis conformation is most stable. So here we get a very important point, that is number of anomeric effect is directly proportional to the stability. Now we will discuss about the criteria for anomeric effect. Anomeric effect will be present only such type of skeleton, that is, suppose X is a heteroatom which has the lone pair over here, and Y is also a heteroatom and it can be halogen also, where X is a heteroatom such as oxygen and nitrogen. So we see that in order to introduce anomeric effect in a system, this skeleton must be followed, and we can see that this lone pair and this alpha and this beta bond are in anti-periplanar position, that is, this is the lone pair and this is the alpha bond with respect to the lone pair, and this is the beta bond with respect to the lone pair. Here we can see that if this is the sigma bond between C and Y, then the sigma star will be over here. This is the sigma star of CY, and this lone pair of X and this sigma star are in parallel position, so this can meaningfully interact with this sigma star. This is how anomeric effect occurs, and this is the skeleton for occurring anomeric effect. Now, why anomeric effect is a stabilizing effect? As this Y is a heteroatom or it can be a halogen, so it must be more electronegative than the carbon. So it drags this sigma bonded electron towards itself and it gets delta negative character, and this carbon gets delta positive character. So this carbon atom becomes electron deficient, and by this interaction between this lone pair and the sigma star of Cy bond, the electron deficiency of this carbon gets reduced. That's why anomeric effect is a stabilizing effect. It actually decreases the electrophilicity of this carbon. So the interaction between the lone pair of X and sigma star of Cy reduces the electrophilicity of the carbon attached to Y. Thus, it stabilizes the system. So that's why anomeric effect is a stabilizing effect. Now we will solve some problems in order to clarify this concept. So in this problem we have to find out the most stable conformation of this compound. We can see that in this conformation 2 chlorines are in above the plane and 2 chlorines are below the plane. But in B we can see that all the 4 chlorines are in above the plane position. So this cannot be the correct conformation. These 2 chlorines, that is alpha chlorines, alpha to the oxygen, are in above the plane, and these 2 chlorines, another alpha 2 chlorines, are below the plane. But here you can see that this is an alpha chlorine and this is an alpha chlorine, but this chlorine is below the plane and this chlorine is above the plane. Here also this is an alpha chlorine, this also an alpha chlorine, this is below the plane and this is above the plane. It does not match with this compound, so it is not with the correct conformation. So our answer will be between option A and option D. Now we have to find out the total number of anomeric effect possible in A and D. So if we draw the lone pairs correctly, it is the axial lone pair and it is the equatorial lone pair. Similarly, it is the equatorial lone pair and it is the axial lone pair. Now look very carefully, this lone pair and this alpha bond and this beta bond are not in actually anti-peripheral position. Actually this bond and these bonds are in anti-peripheral position. Similarly, this lone pair and this alpha bond and this beta bond are not in anti-peripheral position. So here we can see that no anomeric effect is possible. So zero anomeric effect is present. But in option D, if we draw the lone pairs correctly, it is the equatorial lone pair and it is the axial lone pair. Similarly, it is the axial lone pair and it is the equatorial lone pair. Now we have to check the anti-peripherality. If this lone pair is considered, then this alpha bond and this beta bond are in perfect anti-peripheral position. Similarly, this lone pair and this alpha bond and this beta bond are in perfect anti-peripheral position. So here we get 2, and also if we consider this lone pair, then this lone pair, this alpha bond and this beta bond is in perfect anti-plate pair position, and similarly this lone pair and this alpha bond and this beta bond are in perfect anti-plate pair position. So here we get total 4 anomeric effect from this two and from this two. Total 4 anomeric effect is present. Hence, number of anomeric effect is maximum for this conformation. So this is the correct conformation. Now we move on to the next problem. We have to find out in this problem when this R group is in axial position. So far we have discussed that anomeric effect occurs only when the group is an heteroatom or which is polar. But methyl is not a polar group and it actually exists in equatorial position, because if 2-methyl exists in such a way that if here is 1-methyl and here 1-methyl, then a severe 1,3 directional interaction will be present. So here, because steric reasons, this conformation is very less stable. So methyl is the wrong option. If this is a CF sigma bond, then it will be a sigma star of CF. As fluorine is the most electronegative atom, it drags the sigma electron between C and F bond towards itself. So it gets delta negative character and this carbon gets delta positive character. And this carbon becomes electron deficient to some extent. There is a hydrogen in axial position and these sigma electrons are in parallel with this sigma star, then it meaningfully interact with this sigma star. So here interaction between sigma of carbon hydrogen to sigma star of CF. Similarly here also it is a sigma star of CF and it is the carbon hydrogen sigma bond, and it can meaningfully interact with the sigma star as this sigma bond and the sigma star are in parallel position. This interaction is also between sigma of CH to sigma star of CF. As fluorine is most electronegative atom, then fluorine drags the CF sigma electrons towards itself most compared to the chlorine and oxygen. Hence, the carbon becomes mostly delta positive character in case of fluorine than that of chlorine and oxygen. Therefore, the electron transfer from sigma CH to sigma star CF is more readily occurs in case of fluorine. So fluorine is the correct option. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, share and subscribe my channel. Thank you.